Okay guys, so when I'm talking about this lesson, I'm going to be using the formulas these are actually in the back of your textbook. You can see, this is just a copy of it. So you can see the double angle formulas and the half angle identities and the half angle formulas there. So any of those, this kind of middle column there, are really helpful in this lesson. I talked about in class kind of where those came from. You can also look in your textbook for that, or we can talk about it if you have a question about that as well. So let's start out with example 1. They ask me to find the exact values of the sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. And then they give me some information here. So what I'm going to be looking at is those double angle formulas, sine of 2u, cosine of 2u, and tangent of 2u. In this case, theta is my variable instead of u. Okay, so let's start out with what they gave me. They told me that the cotangent of theta is 4/3, which I'm going to take from that tangent is 3/4. So that's important to be able to kind of go into something that makes a little more sense to you and that you can look at your angle and kind of figure out what side lengths we have. So also this piece of information right here, that tells me what quadrant I'm working in. So 180 degrees to 270, that would get me into quadrant 3. So that's important to kind of note. So I'm going to go ahead and sketch out what that might look like. So let me do it over here so I have some space. So I have this angle that's in quadrant 3. So I'm going to put it here. And I'm going to say I've got some y value right here and some x value right here that gets me to that. So this is where that is helpful. This tangent is 3/4. So remember that tangent is I always think of it as y over x or sine over cosine. There we go. You could also think about it as your opposite over adjacent. So in this case, the one thing that I'm going to think about though is that I'm in this third quadrant, which means both my x and my y value are negative. So really this is a -3 over -4 if I'm thinking about it that way. So my x value was a -4, my y value was a -3, which makes this hypotenuse a 5. You can use Pythagorean theorem to help you with that. So now let's talk about those 3 things that I'm supposed to be finding. The sine of 2 theta. The double angle formula I can use for that one is right here. Sine of 2 theta would be 2 times the sine of theta, cosine of theta. So 2 sine of theta, cosine of theta is what I'm using for that problem. All right, so that gives me 2 times the sine of theta in this case. So that would be my sine is opposite over hypotenuse, so -3/5. And then cosine would be adjacent over hypotenuse, which is -4/5. And then if I multiply that, -3 times -4 is 12 times 2, which is 24. And 5 times 5 is 25. So 24/25 is what I was looking for. Okay. The second one that they asked me to find, I'm having a really hard time focusing today. Not sure why. My camera keeps going out of focus. All right, the second one, cosine of 2 theta. The double angle formula I'm using for that one, I'm just going to use this top one right here, cosine squared minus sine squared. All of those are equivalents though, so I could have used those others. All right, so cosine was -4/5 squared minus my sine was -3/5, and that is also squared. So that gives me 16/25 for that one, minus a 9/25 for that one, which leaves me with 7/25. Okay, and then the last one they wanted me to find was the tangent of 2 theta. The formula that I'm going to use for this one is 2 tangent of theta over 1 minus tangent squared of theta. So let me write that out here. 2 tangent of theta over 1 minus tangent squared theta. All right, so that's going to give me 2 times tangent, which I already knew was 3/4. You could use -3 over -4, but I'm going to simplify that and say 3/4 all over 1 minus that 3/4 squared. So really that means I have 6/4 over 1 minus 9/16. So that means I have 6/4 over 7/16, because this is like 16/16. 16 minus 9 would give me 7. So then I think about it like this: 6 over 4 times 16 over 7. And then you can cross simplify if you want, which would give me 24 over 7. Another way that you could have done this problem is you could have said tangent is sine over cosine. So I could have said that this is 24 over 25 times 25 over 7 if I flip and multiply, which also gives me 24 over 7. So either way, I don't care which direction you go with that. Okay, example 2 is asking me if the cotangent of alpha is 2 and alpha is acute, find the exact value of the cosine of 2 alpha. So again, I'm going to think about what this looks like visually. So I'm going to get myself kind of a coordinate plane. This tells me that I'm in quadrant 1 because it's acute, so I have to be over here. And if cotangent of alpha is 2, that means the tangent of alpha is 1/2. So if I'm looking at this right here, my tangent is opposite over adjacent. So there's my 1 and my 2, which makes my hypotenuse here a square root of 5. So how did I do that? I did 1 squared plus 2 squared equals my hypotenuse squared. 1 squared plus 2 squared would be 5, and then square root. That would give me my square root of 5. Okay, but they want me to find cosine of 2 alpha. So again, I'm going to go back to this. My cosine would be cosine squared minus sine squared. Cosine squared minus sine squared. So that's going to give me, in this case, my cosine would be, if I'm looking at this angle, that would be 2 over the square root of 5 squared, minus my sine would be 1 over the square root of 5 squared. So that would give me 4/5 if I square the top, square the bottom, minus 1/5. So 3/5 is my answer on that one. All right, example 3. They want me to find the exact values of these half angles. So theta over 2, cosine of theta over 2, sine, cosine, and tangent of theta over 2. That makes sense. Okay, so now I'm using these half angle ideas. So I'm going to be using this idea down here, these formulas, because that gives me my sine of my angle over 2, cosine of my angle over 2, tangent of my angle over 2, which is what I'm looking for. So let's look at what information they gave us. They told me that the cosecant of theta is -5/3, and from that, I can then take that sine would be -3/5. And I can talk about which one is negative in a minute. This information right here, -90 degrees up to 0, that tells me I'm in quadrant 4. All right, so if I'm looking at this here, I'm in quadrant 4, which is over here. And that tells me that my, if sine is -3 over 5, that means my y value is that -3, and my hypotenuse is the 5, which makes this a 4. Okay, so then now let's go back and find those things that they asked me for. I've got sine of theta over 2, cosine of theta over 2, and tangent of theta over 2. All right, so the first one, my sine, that formula is plus or minus the square root of 1 minus cosine of theta all over 2. In this case, I know that my sine value is negative, so I'm going to only have to worry about the negative one here. 1 minus the cosine of theta. In this case, the cosine of theta would be 4 over 5. Okay, so that gives me a negative square root of 1/5 divided by 2, which is really negative square root of 1/10. So I'm going to multiply by 10 over 10 and see what I get here. So this would give me, I'm trying to rationalize that denominator. So that would give me the square root of 10 on top, but the bottom would just be 10 because that would be the square root of 100. So now I have a better looking fraction there. Okay, cosine, same situation where I have a plus minus. In this case, it's plus minus the square root of 1 plus cosine of theta all over 2. In this case, my cosine value would be positive, so I'm only having to deal with the positive. So that'd be 1 plus the cosine of theta, again, is 4/5 over 2. So really that gives me the square root of 9/5 over 2, or the square root of 9/10. Again, I'm going to take the top and bottom times 10. So that's going to give me the square root of 90 over the square root of 100, which is just 10. But that simplifies to 3 square root of 10, or I could have simplified the square root of 9 here and said that's 3 and times the square root of 10. All over 10. And then the last one, tangent. Tangent is 1 minus the cosine of theta over sine of theta. So in this case, that gives me 1 minus 4/5 all over negative 3/5. So that's 1/5 divided by negative 3/5, or I could write that as 1/5 times negative 5/3, which gives me negative 1/3.